So now what we are going to discuss is about the Bootstrap loader. Okay. Yesterday we have discussed about the absolute loader, and we have seen three processes: the loading, the program relocation, and also the linking. And the Bootstrap loader or this absolute loader, it does only the job of loading. So loading is just loading the object code into the memory for execution. And this Bootstrap loader, it is an example for the it is an example for the absolute loader. Yesterday we have seen that this Bootstrap loader, it will be in the memory, it will be in the address 0. Okay. And generally it loads the object code from a device called F1 into the address 80. Okay. And usually this program would be the operating system, and by that the operating system will first run in your system. So now we'll see from how this Bootstrap loader, it uh, reads the object code from the device F1, and how it loads it into the memory starting from the address 80 for execution. Okay. So we have a algorithm for that, and this Bootstrap loader is designed for the machine SICXC. We have already discussed about this simplified instructional computer, and this XC is an advanced version or the expensive version. Now we have an algorithm for this. So as you can see here, this Bootstrap, it reads the object code from the device F1 and enters it into the memory starting at address 80. Okay, so it is a hexadecimal address, and after all the code has been after all the code has been entered into the memory, then it will jump to the address 80, so it can start. So that is the starting address of the program, object program, that is placed in the memory where it can start the execution, or it can begin the execution that is loaded in that address. So here we have two registers. One is the accumulator and another one is the X register. So initially the A register is set to 0. Okay. So A register is cleared, and then this X register is loaded with the, it is initialized with the address which is going to be executed next. So the next address to be executed or to be loaded is this address 80. So that will be initialized in the register X, load X, hash 128. This is the decimal value, and the hexadecimal value is 80. Now, you can see here there is a loop. So, this process will continue until all the characters from the object program is object code is getting read. Okay. So, in the previous topic in assembler, we have seen a sample assembly language program, and for every statement in the program, we generate an object code. So an object code would generally look like the instruction would be converted into its machine equivalent, and the operand would be also converted into the machine equivalents. So we'll be having an object code something like this for every instruction in the program. Now we have also seen that each of these things which we read from the object program, it is read as a character. Now if you look into a character, it will occupy 1 byte, and hence it will if this two characters will hold 2 bytes in the memory. To avoid that, we want to compress, or we want to compact or pack together these two in a single byte, having each of these bit into a in a half byte. So within 1 byte, both these two characters has to be loaded in the memory. So we'll see how it can be done. So we have a function called getC function. Okay, we have a function getC. Now this is the one which is going to do most of the part in the Bootstrap loader. So this getC function, what it will do is it will read a character, and once the character is read, it will check whether that is the end of the file. If not, it will check, it will compare with the hexadecimal value 30. Why it is so is, um, one second. We have a ASCII table here. If you see in this table, you can see here, starting from the hexadecimal value 0 till 2f, all these are representing the characters which are of which are representing some characters, some symbols, or some the keyboard entries like yeah, tab space, backspace, end of transmission, start of the text, okay, and file separator, escape character. So, and here you can see several symbols available. So till this point, all these are only the symbols, which is definitely not going to be present in your object code. So object code can possibly contain the values from 30 to 39. That is, it represents the values 0 through 9. And also the hexadecimal values can also take the values of A to F, right? A to F. And that equivalent value is 41 to 46. So only these values could be available, and not the values beyond which is less than 30. So that is why we will be checking out what whether the character that we have read, it is either the end of the file character, or it is less than, and we are going to check what is the difference between the value that we have got and the which is subtracted with the value 30. Okay, so that we will check with an example. So every time it is going to get a character, read a character, and it is going to be stored in the accumulator. And every time when you get a character, it is returned to the main program. Then again you will be getting the next character, and we will do the process and see how this 2 bytes of characters is going to be 2 bytes is going to be compressed in a single byte. Okay, so now we have this getC function, so which is going to read the hexadecimal digit from the program which is being loaded. So now we'll move on to the getC function. So what happens here? First, it will test the input device. Okay. So in assembler also we have seen this in both the subroutines and in the main program. In the read record routine and in the write record routine, we have seen that before reading or writing, we need to check whether the device is ready or not. So similarly here also we are going to test the input device, because the object program is going to be read from the device F1. Okay, from the input device F1, the input is going to be read. So we need to first check this particular device whether it is ready or not. And we have already seen this particular instruction. If the result is equal, j equal, then it means that the device is not ready. Then again the function is called. Okay, so again we come back here. It's a loop until it is ready, until the device is ready, it is looping. Once the device becomes ready, then this condition will not be satisfied. Then you come to this instruction. It says that read input. Okay, so read the character. So if we have a object code something like this, okay, so it will first read the first character. Okay, it will read the first character, and once it reads the first character, this one, it has a ASCII equivalent. I'll show you through an example. First I'll just go through the flow of the algorithm, then we'll solve it with an example. Okay, so first, it will read a character and it will be converted into the hexadecimal equivalent, and that will be compared with the value, hexadecimal value 4. Why it is compared with the hexadecimal value 4 is that the hexadecimal value 4, it represents the end of transmission, okay, or the end of file. So when every character is read, it has to check whether it has reached the end of the file or not. So that is why the every character is checked with the hexadecimal value 4. So if suppose if it is equal, if it reaches the end of file, then we have to jump to the location 80, that is memory address 80, where the execution of the program will start. So it means that we have read the entire object program from from the device F1, and it is loaded into the memory from the address 80. Okay. So if not, okay, if it is not equal to 4, then come here. So now you have to compare with the value, hexadecimal value 30, meaning that the values before 30, as we have seen in the ASCII table, they are all representing some symbols and the characters from the keyboard, which is not relevant in the object program. Okay, object program will not contain those symbols or the other keyboard symbols. So we are going to check whether it is, we are going to subtract this value 30 from the value that we are getting for this particular character. So we will be subtracting it and we'll see what is the result. If the result is less than 10, okay, if the result is less than 10, then it means that the conversion is complete and we can return this value to the main program. Okay, you can return this value to in the main program and you can continue. Otherwise, if the result is greater than 10, okay, if the result is greater than 10, then it means that again you have to subtract 7 from that value. After subtracting whatever the value that we are getting, that we have to return to the main program. So in the main program, when it comes, so we have got one character and that is now available in the accumulator register A. And now what we have to do is we have to move that value into S register, and then we have to shift the register by 4 bits. Then again we have to call the getC function. So now what happens in this function is we are calling the function and we are reading the first character. For example, if we have 14, then the first character is read using this getC function when we call that, and now this will be stored in the S register. Now again you are calling the getC function and you read the character 4. Now after reading this, now what we have to do is Now, after reading this character, again, this will be we will be come back to the main program, where the next instruction is add registers S and A. So previously, the value of 1 that we have processed, it is available in the S register, and the second character that we have returned is present in the accumulator. Both these register values we have to add. So now, after while when you are adding these two, what we are getting is we are combining these two digits in a single byte. Okay, and again we will be storing that particular it is going to be stored at the address in register X. What is in present in register X? The address 80. So now we have found this, we have read these characters from the object code, so that will be stored in the memory. Okay, and then this process will happen until we are going to completely read the entire object program and read all the characters from the object code. Okay, so this is the process. We'll see an example now. So the object code that we have taken here, for example, is 17202D. Okay, so this is the object code we have taken. Now, what I have done here is, so the object code is written here in the first row, and in the second row, we have a ASCII value, that is equivalent value for this each of this digit in the object code. And then we have the accumulator and then the register yes, and this is the process that we are going to do for value present in the shift register. In the S register, that we are going to do the left shift, okay, 4 times. So first, initially we call the function get character, get C. Okay, so this function is called, and we get the okay, we read the input character. So what we have read is the character 1. So now the ASCII value for this is 31. Okay, so if you have you can see here the ASCII value for the character. So the third column is character. So the ASCII value for, you can see here, the ASCII value for the character 1 is 31. Okay. And so now what we have to do is the it will compare the value with 4. Okay, it will compare the value with 4. So we read the character. Okay, we read the character 1. So convert it into the ASCII value. So that is 31. Then what you do is compare with hexadecimal 4. Okay, so why hexadecimal 4 is that we need to check whether it is the end of file or not. So if it is not, okay, since this is not the end of the file, then you go to the next comparison, that is we are going to so this value is 31. This is going to be subtracted from the value 30. Okay, subtract hexadecimal 30 from the ASCII code. So this arithmetic operation, this subtraction is going to happen in the accumulator. So 31 minus 30 is equal to 1, and that you can write it as 0, 0, 0, 0, 0, 0, 0, 1. Okay. And the next step is, after subtracting, you check the value. Now the result is 1. We have to check whether the result is less than 10 or greater than 10. So since here it is 1, it is definitely less than 10. So it means that the conversion is complete. So what we have to do is, when it is less than 10, return. Okay, that means the value is returned to the main program, and so the accumulator value, it is having now this 1, which is less than 10. So here, as we come back to the main program, the next step is move the register A to yes. That means we are going to move the value that is present in register A to yes. We are going to save it in the register yes. So the same value that is present in register A, it is going to be saved in register yes. And the next step is shift L S comma 4. So the S register, we are going to shift it 4 times to the left. I hope you know how to do the shift operation. If you do not know, please listen. Okay. So when you shift it for the first time, so we are shifting it in the left. Okay, 1 bit. So the first bit goes out, and this bit comes here, this 0. Okay, this bit comes here, then the next bit. So every bit is shifted towards its left. Okay, and so you have one more position vacant that can be accommodated with 0. Then again the next time, so first time we have shifted, then second time, third time, fourth time. Okay, we need to shift it 4 bits. So as you shift 4 bits, what happens for the second time? What will happen? This 0 will go away, and all these bits will move towards the left 1 bit, and the last bit position will be added with 0. Okay, and again the third time, third time when you shift, this 0 will go out, and all these bits will shifted 1 time towards the left. So again the last position will be vacant, which will be added with 0. Then similarly for the fourth time, this 0 will go out, and all the other bits will be moved 1 position to the left. Okay, so finally we'll be getting, so if you know the shifting, you can do it directly, right? So all these 4 bits, because we are going to shift 4 bits to the left, so all these first 4 bits will go away. So these 4 bits come to this position, and the remaining bits will be 0, 0, 0. Okay. So now this is the content of the yes register. Okay, this is the content of the yes register, and you can see what happens after this shift operation. Again it calls the getC function. Again it jumps to the getC function, so it is going to get the next hexadecimal digit. So in our case, the next hexadecimal, next character is 7, and its hexadecimal equivalent is 37. Now again the same process. It will compare it with the decimal value 4, hexadecimal value 4, to check whether it is end of file. If not, then it will subtract this 37 from 30 with 30. So what we will get is 7. Okay, and when you get the result, you compare it with the value 10, whether it is less than 10 or greater than 10. So obviously 7 is less than 10, and its equivalent is, okay, 0, 0, 0, 0, 0, 1, 1, 1. Now, now the next step is you can see here. So using this getC function, we have read this character and we have found the value in the accumulator. Okay, and what this getC function will do is it will, after checking whether it is less than 10, it will return that character to the main program. So as we are getting the accumulator value with this 7, the next step here you can see that we need to add the two registers. Okay, so now what is present in S and A? Now presently A contains this value and S contains this value. Okay, so now these two registers has to be added, and we need to save that. We have to put that value into the register S. So after adding S and A, the result will be again stored in the register S. So what are the two values? S is having 001, 0000, and A is 0000111. Okay, so we need to add these two values, and that will be present. Now if you see here, the characters, the first two characters what we have read is 1 and 7, and initially it was read from 2 bytes. Now you can see that it is compacted into a single byte. This first 4 bits gives the value 1, and the second 4 bits gives the value 7. Okay, so this 1 and 7 are now compacted together into a single byte with only 8 bits. Okay, so after this, again the shift left operation. So what happens? All these first 4 bits will be shifted to the left, and what you will be getting is, okay. So currently, S will be having this one. Now, again, the loop will continue. So we need to go to the label loop where we are again going to call the next characters. Okay. So the process will continue. So what is the value for this? Okay, give the answer for your poll quickly. Within 30 seconds, I'll just close that. Quick. In another 20 seconds, I will close the poll.
Ma'am, where to access the poll, ma'am?
Are you checking in your mobile or
Laptop, ma'am.
okay, in laptop it will be shown in your screen automatically.
It's not available here, ma'am.
Or others are getting, many have already responded.
Okay, ma'am, I'll see to it, ma'am.
In laptop, it will be shown. Okay, I'll end the poll now. So most of you have given the right answer, but still there are few who have not given the right answer. As we have seen in the ASCII table already, the value for 2 is, okay, we have seen already that starting from 0 through 9, the values will be from 30 to 39. Okay, for 1 it is 31, 2 it is 32, and so on. So okay, so the value is 32. Next, we need to compare it with the hexadecimal value 4. So to check whether it is the end of file. Otherwise, we'll compare with the or subtract the value with 30 and we get it as 2, and 2 is less than 10. So we can return this value. Okay, so the value of 2 is 0, 0, 000010. Okay, so this is now currently present in the accumulator, and as we come to the main routine, the next instruction is to save this value into the yes register. So we copied that value from accumulator to yes register. Okay, from the accumulator we are copying that into the register yes, then shifting it left for the shifting it left 4 times. Okay, so again another poll has come. Please answer it. What is the next value for that? What is the shift L? Quickly answer.
Excuse me, ma'am.
Yes.
Actually, before shifting, should we need to add it with the previous value of S, ma'am?
Ah, yes, yes. No, no, no. Now we are getting the first character only.
Okay, ma'am.
Only when you come to the next get C function only you'll be adding. Okay, now we are getting the first character.
Okay.
Uh, every pair of characters from the object code. So because once you get the first character, you save it in register yes, shift it, then get the second character, then you add it with the registers. Okay. Uh, then when you combine the digits to form 1 byte and then you store it in the address, then go back and get the next character. So every 2 characters will be going through this process continuously until it reaches the end of the file. Okay, quickly answer it. I'm going to close it. Okay, let me end the poll. So Almost most of you have answered it rightly. So the shift value will be 00100000. Now after getting the first character and shifting it 4 bits in the left. Now again we are going to call the getC function to get the second character. Okay, so the get second character again, what it is 0. Okay, so the ASCII value for that is 30. So in the accumulator again, then again we'll be comparing that with hash 4, that is hexadecimal value 4, and it is not equal to that. Then you subtract that value with 30, you will be getting 0, which is less than 10. So you can return this character to the main program. So it comes to this point. Okay, so because you call the function getC from here, and the next instruction is add register S and A. So this is the place where we are going to add the S register and the A register. So this is what is present in the S register, and this is your A register now. So when you add it, so you can easily look into that and add it. So you'll be getting 0010. I hope I'm not confusing you. Okay, this is your S register, and the A register we are having all zeros. Okay, when you add it, you'll be getting 0010, then followed by 000. Now you can check that you'll be again compacting both the characters into a single byte. The value of the first 4 bits, it gives you 2, and then this is 0. Okay, that is what the next 2 characters is about, 20. Okay, so now you can now this will be stored in the address X. Okay, so these 2 characters from the object code. First, initially we have stored this in the address 80, and this address will be now incremented because in 80 we have already stored the first part of the object code. Then you can see add 1 to memory address being loaded. Okay, so it is incremented already, and now the next thing will be loaded in the next memory address, and then again loop, again you go and read the next thing. Okay, so so quickly we'll go through it. Here it is again 2, so we can let me put it fastly. 32 minus 32, and in S register again copy it, and then you shift left 4 times. Okay, the next part is little, we need to look it into it because we have the value of D. Okay, so the if you check in your ASCII table, the okay, if the character is D, okay, if the character is D, its ASCII equivalent value in hexadecimal is 44. Okay, the character that we have read is D, so its ASCII equivalent in hexadecimal value is 44. So now you are getting the value as 44, and it is not equal to hexadecimal 4, so that is not the problem. Next you will be comparing, subtracting this with 30, so what you are getting is 14. Okay, so far all the values we have got which is less than 10. Okay, but 14 is not less than 10, but it is greater than 10. So you can see here when it is greater than 10, okay, if the result is less than 10, the conversion is complete. Otherwise, subtract 7 more. Okay, so again we need to subtract 7 from this. so that you will be getting the value as 7. Sorry. So this is hexadecimal subtraction, not simply 14 minus 7 is 7. So hexadecimal subtraction, how will you do? You have to borrow, and so when you borrow, this will become 0, and here you will be borrowing the hexadecimal, because in hexadecimal, in every power it is 16, right? So 16 plus this 4, so 20 minus 7 is actually 13. So what is the hexadecimal value for 13? It is D actually. Okay. Okay, that we have to check in the hexadecimal too, not in this table. This is character to. Okay, you can check from some other table. So this value, it is equal to D. Okay. Now this values binary equivalent would be 0000 and 1101. Okay, if you are not comfortable with this conversions from binary to hexadecimal and so on, you just please check later. So the D value is 00001101. Okay. So now what we have to do, so this is the S register and this is the A register now, and now we have to add the registers S and A. So when you add S and A, what you will get, 0010 000 and 00001101. 10110100. Okay, so 0010 and 1101. Again, if you see, these two characters are compacted in a single byte. So the first 4 bits represent 2 and 1101 represents D. Okay, so like this, all the object code from the device is it will be read from the F1 device through the absolute loader into the memory, and once it encounters the end of file, then it jumps to the memory address 80, and so here it keeps on loading the. Okay, so in every consecutive bytes, it will be keep on loading the values. Then once the end of file comes, it jumps to this location and starts executing. Okay, and that would be the operating system, obviously, and you'll be the operating system will be loaded into your system. Okay, and one more thing to note down here is, since this is a very special program, the usually we have seen that the object code has 3 different kinds of records, like header record, text record, and end record. Okay, but this program that is present in this device, it should be very simple, without having much information, like a header or end record is not needed. Only absolutely the object code only should be there, so that it would be easy for the Bootstrap loader to read the object program and load it into the memory. Okay. Okay, the final poll, please attend it. If you have any doubt, you can ask later. Okay, I'll end the poll.